Alright, in this video we're going to look at how to do the problems such as this one in your book, number 15, which deals with an FN4 fit. There's also number 16, how to do these RC1, what all this means. So in your book you have charts. Okay. Three charts I want to look at. One here is the RC fits, running and sliding fits. All right. And the way this works is that these limits are in thousandths of an inch. So based on your nominal size over here, so if our size is let's say 1.5, that's in this range. This is the limits of clearance. This is a clearance fit. RC is a running clearance fit. So you have a clearance of 0.4 thousandths. So that's written 0.0004. And or do you have a clearance of 1.1, which is 0.0011. So that's how that fits. That's how this. If you didn't have those zero, they move the decimal point 3 places to the right. If you had it to the left, you'd have a bunch of zeros in your chart, which makes your chart a lot bigger. So that's how you read that. So you get your nominal size, and you look at what, if it's an RC1 fit, you're up here. If you're RC2 fit, you're here. And I first look at these column here. It shows you how much clearance you have, 4/10 or 1.1 thousandths. And then this is what you do the whole. For the whole, you add 0.4 and minus nothing, and to the shaft you subtract 0.4, subtract 0.7. Alright, so let me find that problem. If we have a problem, well, let's just do it. Let's say you had your shaft that was 1.5. How's it going to look? Well, if this is the shaft, okay, and then there's the collar, center line, hatch. All right, so there's the shaft. So if it's 1.5, I'll make it a basic size, 1.5. All right, and then we add, I'm sorry, for the shaft we subtract 0.4, subtract 0.7 off the shaft. So there's the shaft. All right, so subtract 0.4, subtract 0.7. So if I take 4 off of it, I get 1.4996 and 1.4993. That would be the diameter of the shaft. All right. So if I subtract those two from the basic size, that would give me that size of a shaft. And if you look at the collar, basic size 1.5, and they say just add 4/10 and subtract nothing. So it'd be 1.5004, 1.5000 would be the size of the collar. So the MMC would be this one. The MMC would be this one. So you bring the MMs together, you got your 4/10. You put the LMCs together, you got your 1.1. So that's how the chart works. So it's going to do, let's see, there's one here for RC. If we go to the other side, we have this one here, which is an FN. The FN is a force fit. Okay, it's a force fit. And let's look at the problem we have. So they're saying, let's look at the problem here. It's an FN4 fit. Basic size are 1 inch. And they want to use limits dimensioning. I use my FN. I think I've got the chart here is already set up. So there's your nominal size, 1 inch. FN4 is here. Okay, bring it down. There's your, since it's a FN, it means it's a force fit. It means you have to press it together. And it looks like the limits of interference in this column would be 1 thousandth, so that's 0.001 thousandths interference to 2.3, which would be 0.0023. Or I could add another 0 to make them the same. So from 1 thousandths press to 2.3 thousandths press in this. So based on the hole in the shaft, we'll look at what they want. So on the hole, they want plus 8/10, and on the shaft, they want 2.3 bigger, 1.8 bigger. So let's do the problem here. So there's the shaft, and again, basic size is 1 inch, 1.000, and the 4 place, and diameter. All right, we'll do the, which one do you want to do first? We'll do the hole. The hole is plus 0.8, so we plus 0.0008 and minus nothing. So subtract nothing. Notice if I got 4 place here, I got to have 4 place there. So if I do this, I got 1.0008 and 1.0000. That is the final. That is in limit form, correct? I'll put a box around that to denote that is the correct. Okay, because it does say limit dimensioning. And for the shaft, we are going to do plus 2.3 plus 1.8. So we go plus 0.0023 plus 0.0018. Okay, so just add that to the basic size and you'll have 1.0023, 1.0018, just like that. And there's your answer for that one, for the FN4 fit. MMC of the part would be the bigger, right, which would be this, so we denote that at MMC, and that would be the LMC. Over here, this would be the MMC, the smaller, and this would be the LMC. So you put the M's together, you got 2.3 interference, and you look at the L's together, L to L, you've got, looks like 1,000ths interference, so it matches that. So that's how you use the charts. These are in any machinist handbook. And there's another one for an LT fit. That's RC. I think it's underneath here. Yeah, you have one for a LT. This is a transition fit. So when they say fit here, it could be press or slip. And based on the homework assignment, there's your nominal size. It's within this range. That's the LT3. There's no values here because they didn't have anything in this size range for LT3 or LT4. Again, you need to move the decimal place 3 places to the left when you're doing the problems, like here. Okay. And so you'll have a couple homework problems on this.